Okay, guys, so today's topic is inequalities, and this is, I suppose, in contrast to equalities. So normally we talk about equalities or anything to do with the equal sign, but in this case we're talking about inequalities, which is, I suppose, four new symbols which we need to understand how to use. So these are the four symbols. We have this less than, a greater than, equal or less than, or an equal and greater than. And you would be familiar with these from a lot of different examples beforehand, but let's just go through some examples of how we would use these in general. So if we were talking about here's a square and here's a greater than a small square. So this square here is bigger than this square here. Now if you forget which way the symbol works, it's always the bigger symbol. The bigger end of the symbol points to the bigger part of the inequality. So the small end of the inequality points to the smaller part of it. So another example of that might be if we actually use some numbers. 8 is greater than 4. Okay. We could talk about x is greater than y. X and y can be anything we want. Okay, so that's for this one. What about when we look at an equal or less than, or an equal greater than? So this essentially means that it has to be either bigger or can be equal to. So if we were to look at an example of numbers, well, 8 is equal or greater than 8. Well, because of the equals part of that. It doesn't really make a lot of sense to say that. What we could say is that 8 is equal or greater than, let's go, 8, 9, 10, 11. And that could keep going on forever, couldn't it? Because all of those numbers would be represented by this symbol. All of those numbers are either equal to or greater than 8. Okay? So that's the equal than or greater than or equal or less than sign. Okay, so we want to think about how we represent this graphically. So let's just talk about if we said x is greater than 2. Okay, so this, if we think about the numbers of this could be anything from, if we think about integers or whole numbers, it could be anything from 3, 4, 5, etc. Okay, and all we do to graph this is we just have a straight number line, and let's just put a 0 mark in here. And all we do is we just think about all the numbers that are greater than 2. So if we put in 2 here, 4 here, 6 here, we just put on a dot. Oops. An open dot and say, well, it's any of those. Okay, so there's something that's important here. I've used an open dot because it's not inclusive of the 2. Okay, it doesn't include the 2. Okay, there's not that. Okay, so how would that be different then if I looked at doing x is equal or greater than 2? Well, all that would do is we'd just go a closed dot. So we'd go closed dot greater than 2. So this means it's inclusive of 2, whereas this one here is not inclusive of 2. Okay. All right. Let's get a little bit more complicated. So what happens if we said, okay, x is equal to 2. Well, what about if 2x is greater than or equal to 6? Well, we treat this as though it's an equality, not inequality, and we can rearrange it. So what we do is we just grab the 2 and we move it to the other side. And because this is a multiplication sign hiding in here, then we just obviously do divide. So we have x is equal than or greater than 6 divided by 2. So x is equal than or greater than 3. This whole process is called solving an inequality. Okay, because this is it's like an equation. it's an inequality because of this symbol, but we're really trying to find out, well, what x value will satisfy this inequality. So we rearrange it, and then we can do a nice graph again with 0, 3, 6, and because of this symbol here, we're going to do a closed dot at 3. It could be anything greater than that. Okay, so this has infinite solutions, doesn't it? Because if I were to say, well, x is equal to 10,601, well, that's fine. Yeah, that satisfies this inequality because x is a number that's greater than 3. So that's fine. All right, what about if we have something slightly more complicated? Let's have 2x plus 5 is less than or equal to 7. Okay, again, we just assume that this is the same as an equation, and we rearrange it in a similar way. So I'm going to bring my 5 across. So I have 2x is equal or less than 7, subtract 5. So 2x is equal or less than 2. And then I can rearrange this by dividing. Okay, so I'm going to bring this across. So I'm going to have x is equal or less than 2 divided by 2. So x is equal or less than 1. Okay, so if I'm going to graph this again, I'm going to have 0, I'm going to have 1, I'm going to have, negative 1, 1. And I'm just going to put in a line here, less than 1. Now, this, because remember, this here is equal to or less than 1, I need to shade this in. And make that a little more round for those who are struggling with that. Oh, that's good enough. Okay, and that's really inequalities. There's one last trick. What about if we said, well, minus x is greater than 2. Minus x is greater than 2. We want it to be x is greater than something. So how does this work? Well, if we were to try and think about how a negative works, if we were to just grab this and move this over here, this is like I could rewrite this as minus 1 times x is greater than 2. Oh, that's all it's saying. So if I was to move my minus 1 over, I would go x is greater than, struggling to delete. Let's go, there we go. X is greater than 2 divided by minus 1. Okay, so x is greater than or equal to, if I'm dividing by minus 1, it's the same as minus 2. Now, we have a bit of an issue with this, because if I think about x as being greater than minus 2, then that could be, let's just think, it could be minus 1, it could be 0, it could be 1, it could be 2. Keep going forever, okay, because it's got to be greater than minus 2. But let's check that with our original thought. So if we go back to this, or even back right to our starting point, minus x is greater than 2. So let's substitute in, let's say, 1 into that. So if we substitute 1, then we go, okay, minus 1 is greater than 2. So we've got an issue, don't we? Because minus 1 is not greater than 2. Okay, if we think of our number line, it's definitely to the left of it. So during this process over here, we actually have to do something. And the rule is, if you're ever dividing or multiplying by a minus number, so it's any number with a negative sign in it, you have to change the sign. So let's do this again. So we had minus x is greater than 2. So what we do is we still divide by the minus 1. So effectively we take the minus to the other side. But what we have to do is we have to change the sign to the opposite sign. Okay? So now when we look at this, well then x could be anything like minus 3, minus 4, minus 5, etc. Okay, and we could check it. We could check to see if this works back into our original. So let's substitute it in. So let's go with minus 3. So minus, that's that minus, and then I substitute in my value, minus 3 is greater than 2. Is this right? Well, my negative and my negative make a positive. So I end up with positive 3 is greater than 2. That's true. Yeah, 3 is bigger than 2. So it works as long as we do this trick where we flip the sign if we've got a negative in there. Okay? And that's inequalities.